point-slope form looks something like this. What I like to do is manipulate it and just solve for y. So I'm going to add y1 to both sides. So the point-slope formula I like to use is y equals m x minus x1 plus y1. And this is just a manipulation of the original. So if I'm given a slope and a point, that would be a great time to use point-slope formula. And it looks something like this. Y equals 2/3 parentheses x, and this piece means the opposite of x or the change of the x value. So if the x is 4, the change of it is the -4, and then the y value goes at the end, and since it's positive, I'll leave it positive. So I'm going to distribute, so I get 2/3 x minus 8/3 plus 2. The last piece I'm going to do is combine my like terms, then I'll have an equation of the line. So the final solution is y equals 2/3 x minus 2/3. The next problem gives you 2 points. Now the formula here is a point and a slope, so I need two things. I need a point, which I have 2 of them, and I need a slope. So the first thing I'm going to have to do is find the slope. And to find the slope, it's the change of y's, so 3 and -4, over the change of x's, 4 and -4. So the top is 7 and the bottom is 8. So my slope is 7/8. So I'm going to take a slope and a point, and it doesn't matter. I'm going to choose this one only because I'm dealing with less negatives. So let's plug it into the formula. Y equals the slope of 7/8, x, and again we're using this point, the change of x plus y. So I'm going to distribute 7/8 x times -4 is -7/2 plus 3. The last step is to add my like terms. So my final solution is y equals 7/8 x minus 1/2. And what I would do if I was you is I'd plug this into my calculator as y equals, graph it, and then press second graph, which you'll get to your table, and check on that table to make sure both of those points are there. If they are, you know your equation is done correctly.